and welcome back to EDUHUNT classes where you can excel your academics. In this particular video, we are going to learn regarding the classification of soluble bases or alkalis from the chapter 1 of 7th grade, that is acids, bases and salts. Okay, so we already classified regarding the acid classification, right? In that particular acid topic, that is into acids are classified further into 7 broad categories. Yes. So here in this particular classification of bases, we are going to learn regarding the 3 main broad categories of the classification of soluble bases, also called as alkalis. Okay, here we go. Shall we start the session? Oh yes. Okay, shall we start? We will start. Okay, now, okay, here we go with the classifications of the soluble bases or alkalis. Okay, classification of soluble bases are also called as alkalis. Yes, ALKALIS. What is maybe alkali, children? The base which is soluble in aqueous solution is called as alkali. Very good. The base which is soluble in aqueous solution is called as an alkali. Here simply we can write soluble base is equals to alkali. Okay, alkali. Now here we can also say that on the basis of the solubility of the base, the bases which are soluble in aqueous solution is called as an alkali. Okay, clear now? Now coming back to the classification. So into how many broad categories the bases are classified, children? I told you, no, there are 3 broad categories. We'll see what are all the 3. Okay, 1, okay, and 2 and 3. How many? 3 classifications. Yes. So first one is called as on the basis of strength. On the basis of strength. Yes, on the basis of strength. Now second one on the basis of concentration. What is that, children? Concentration. Now third one on the basis of acidity. On the basis of acidity. Children, did you see any word regarding basicity in that particular classification of acids? Yes, right. So here it will be acidity. For acids we wrote basicity, right? Here for bases we will write acidity. Okay. Yeah. So here we have the classification regarding like this, and you know what happens on the basis of strength, on the basis of concentration and on the basis of acidity, bases are again classified into the particular subcategories. You know what are they? I'll write here for you. On the basis of strength, acids are classified into 2 main types again. Those are called as on the basis of strength. On the basis of strength, those are classified into strong bases and weak bases. Strong bases and weak bases. Okay. Now on the basis of concentration, they are classified into 2 main types again, namely concentrated bases, and other one will be diluted bases. Clear? Now on the basis of acidity, it is further classified into 3 main types. How many, children? 3 main types. 1, 2 and 3. You know what are they? They are named as like this: monoacidic bases, diacidic bases. One second. Okay, we'll write like this: monoacidic bases, and the continuation will write here. Okay, downside. Clear? Yeah. Diacidic bases, this is C, and last one is triacidic bases. What is the last one, children? Triacidic bases. Triacidic bases. Clear? So on the basis of strength, concentration and acidity as well, the bases are again classified into on the basis of these things. Okay, on the basis of strength into strong bases and weak bases, on the basis of concentration, concentrated bases and diluted bases, and the last on the basis of acidity into monoacidic bases, diacidic bases and triacidic bases. Okay children, here we go with the representation of the particular flow chart of the classification of soluble bases or alkalis based upon their three. What are three? First one is on the basis of, repeat after me, strength, very good. Second one on the basis of concentration, very good. Third one on the basis of acidity. Clear? Now we'll go with the first classification, that is on the basis of strength. On the basis of strength, okay, into what? In two categories. What are they? Strong bases and weak bases. Here we go with the heading on the basis of strength. Okay, on the basis of strength. Okay, now to discuss this, I just want to write regarding how the strength of a base is calculated. Okay, we know that alkali is nothing but a soluble base, right? I'll write it here. Alkali, which is known as a soluble base, undergo dissociation in aqueous solution. I told you, this alkali will soluble in aqueous solution, right? It undergo dissociation, in the sense it dissociates into particular ions. So we'll see what is that. Aqueous solution. Okay, all the alkalis, you can write here S also. Okay, bases. So the alkalis which are known as a soluble bases undergo dissociation in the aqueous solution. Okay, so after dissociating there will be some degree. Yes, yeah, the degree of dissociation of an alkali, okay, after the dissociation it will be having the value, right, the calculated value. For that I am telling you again, the degree of dissociation of an alkali is in the soluble basis. Okay, the degree of dissociation in alkali in the aqueous solution is called the strength of the basis. Okay, so at particular what they are undergoing, children, the degree of dissociation of an alkali in the aqueous solution is called its strength of the particular basis, we can say. Okay, or the alkali basis or the alkali. Okay, so here if you observe how to calculate the degree of dissociation, similarly with that of classification of acids based upon the strength, we gave some alpha value. What is alpha value? The degree of dissociation, right? Here also we have the mathematically the degree of dissociation. Okay, mathematically the degree of dissociation is given as the formula number of dissociated alkali molecules, spaces needed a bit. Okay. Okay, yeah. So dissociated alkali molecules, okay, by number of total alkali molecules, okay, into, very good, into 100. This is the mathematical derived equation for the degree of dissociation. What is symbol, children? The symbol for degree of dissociation? Very good, alpha. What is that? Alpha. Okay, mathematically the degree of dissociation we can write of an alkali. Okay, especially we are writing for an alkali, no? We can write for that also. Of an alkali. What is symbol now? Symbol represents alpha, yes. Okay, the number of dissociated alkali molecules by number of total alkali molecules into 100. Same as that of the formula of acid classification based upon strength. Okay, here also we can write like this. Got it? Now, so after this calculation of this, on the basis of this classification, we can say the bases are classified into strong and weak further. Okay, I'll write here, on the basis of degree of dissociation, on the basis of degree of dissociation, the bases or soluble bases or alkalis are classified into what? Two main types. No, what are they? Yes, very good. Strong bases and weak bases. Got it now? So how we are going to derive this strong and weak base on the based upon strength, we said simply. But how this happened? From where we are deriving the strength? How we can calculate the strength of a particular base? It is based upon the value of degree of dissociation. Okay, once again here, on the basis of strength, alkalis, which means the soluble bases, undergo dissociation in the particular aqueous solution. Okay, so upon the degree of dissociation of an alkali in the aqueous solution is called as strength of a base or the particular alkali. Okay, so mathematically if we derive that, we got the formula regarding alpha is equals to number of dissociated alkali molecules by total number of alkali molecules into 100. And next, on the basis of this particular value, how much we got, based upon that we can say it is strong or weak. Okay, based upon the classification regarding that. Okay, on the basis of degree of dissociation, particular alpha, the bases are classified into further strong bases and weak bases. Okay, clear now? Now, upon this strong and weak classifications, we can do the differentiation like this. Okay, differentiation like this regarding strong and weak bases. Okay, first one is regarding which base? Very good, strong base. Strong base. Now, second one is weak base. Very good. Okay. Now, what is strong base? The definition of strong base. What is a strong base? According to degree of dissociation, if the number of dissociations is made in the sense more, large in number, we can calculate it as strong base. If the value of alpha is more than 30%, we can call it as degree of dissociation. Very good. In the previous page, if you observe, we can write here strong bases are having the degree of dissociation value of alpha, which is greater than 30%. Greater than 30%. Now here, for the weak bases, the alpha value is less than that of 30%. Okay, like this we can derive the strong bases and weak bases. Clear now? This is the given thing. Okay, okay. Here I'll include here. Now, for strong bases, the alpha value will be more than 30%. Here, for the weak bases, the alpha value will be less than 30%. Clear, no? Up to here, you are clear, right? Yes. So now we will write definition of a strong base. Okay. Here we go. The base or the bases which undergo complete dissociation. What, children? They undergo complete dissociation in an aqueous solution. In an aqueous solution. Okay, after undergoing, what it produce? It produce more number of hydroxyl ions, because why? It is undergoing complete dissociation, no? So, to produce high concentration of hydroxyl ions. Which ions, children? Hydroxyl ions. Represented hydroxyl ions. How can I represent hydroxyl ions, children? Very good. OH minus. I'll let continuation here. OH minus ions. Okay. Are called as nothing but strong bases. Okay. Are called as strong bases or strong alkalis. Okay, strong bases or alkalis, strong alkalis. Okay, did you understand, children? Okay, once again should I? Okay, listen carefully. Wherever you see the base which is soluble completely, undergoing dissociation completely in the aqueous solution, is called as a strong base, and it produces, upon dissolving, it produces high concentration of which ions? Hydroxyl ions. Which ions? Hydroxyl ions are called as strong bases. Representation of hydroxyl ions? OH minus. So the bases which undergo complete dissociation means what? Completely karigipovam. Okay, karigipoyi, what happens? It will dissociate into OH minus ions. Okay, so in the aqueous solution, to produce high concentration of hydroxyl ions. Which ions? Hydroxyl ions. Okay, upon dissolving, upon dissociating, it produces high concentration of hydroxyl ions. Is called as, the bases are called as strong bases or strong alkalis. Very good. Now, opposite to that, if we write the weak bases definition, it is quietly opposite to that. Okay, here the bases which undergo complete dissociation, right? Here it undergo not complete one, it is called as partial dissociation. What is that? Partial, in the sense not completely, like we'll say like that, half of. Okay, the bases which undergo which dissociation, children? Partial dissociation in what? In an aqueous solution. In aqueous solution. Okay, next continuation. So as to produce which concentration of ions, children? Here it is high, here it will be low. Very good. Low concentration. Continuation here. Low concentration of which ions? Very good. Hydroxyl ions. Hydroxyl ions. In the sense, representation of hydroxyl ions, OH minus ions. Okay, hydroxyl ions, the bases, those bases are called as weak bases or weak alkalis. Okay, weak alkalis. Got it? So wherever you see the dissociation of the bases which undergo partial dissociation in an aqueous solution giving rise to producing low concentration of hydroxyl ions, are called as nothing but weak bases or weak alkalis. Okay. For clear representation, I want to write one more for you, one more slide. I want to show you clearly how to just represent all this thing. Okay. Okay, I'll write this also. Alright. So here we are going with the strong bases as well as with weak basis classification. Okay. Now, if I consider taking a beaker, okay, if I take beaker, okay, for that if I added, okay, for that if I, here similarly if I take the beaker, okay, if I take this beaker, okay, here if there is a solution, we just added base in the particular aqueous solution. So all it is considering a aqueous solution. Okay, this is aqueous solution. The blue color one is aqueous solution. Okay, it may be water or it may be any other. Okay, clear? Here also aqueous solution. Okay, so we are considering taking a beaker, and to that we are adding the particular bases. Oh, we are adding bases. So what happens, you know, if it is represented like this, so if I add any base such as if I add any base such as NaOH, okay, it dissociates into, if I add any NaOH, it dissociates into 2. What is that? Na plus sodium ion and OH minus hydroxyl ion. Yes. So here in the particular beaker, if I add NaOH, which means a base, okay, you know what happens? The Na molecules, which means the sodium ion molecules, are separated, and also OH minus are also, you know, they are separated like this. Okay, we can calculate, no, NaOH into Na plus and OH minus ions. We can write this as which ion? This is hydroxyl ion. Okay, and this is sodium ion. Okay, so here we can observe the representation of like this. If we take some quantity of NaOH, if we add in the particular beaker containing aqueous solution, the NaOH molecules will dissociate into particular sodium ions and also OH minus ions, which means Na plus ions and OH minus ions. You know why? Because the strong bases such as NaOH undergo complete dissociation in the aqueous solution. Okay, we can see here complete dissociation, in the sense it is dissociated completely. Dissociated completely. Okay, clear? Similarly, if I take any weak base, for example, if I take weak base such as MgOH twice, MgOH twice, okay, it will give further ions after dissociating into Mg plus 2 and OH minus. You know what is this OH minus? Very good, hydroxyl ion. Then what is Mg plus 2? Magnesium ion. Okay, so this is the dissociating into Mg plus 2 and OH minus ion. Okay, what happens here? The particular Mg plus 2 and OH minus ions will undergo only partial dissociation, in the sense they are not completely dissociating. It will be like this only. See, if these are Mg magnesium plus 2 molecules, okay, the OH molecules are attached to this only. Okay, it will not completely dissociate, partial dissociation goes on. Wherever we can find some or no, okay. Some may be present with dissociation, but many of them are not undergoing any dissociation. So this is classified as undissociated. What is this? Undissociated. Did you get now? Okay. If the molecules are separated upon dissociation in the aqueous solution, those are named as strong bases, such as NaOH, dissociation, clear observation of the particular diagram, dissociated molecules. Whereas in weak bases, we undergo partial dissociation, in the sense it is not completely separating. It is like attachment of molecule only, MgOH twice. But whereas only few, in the sense partial dissociation happens, in the sense only few are dissociating, but remaining maximum are not dissociating. In the sense we can write the word undissociated. Clear? This is the diagrammatic representation of particular strong base and weak base representation in an aqueous solution. We should definitely take an aqueous solution, children. In that only we can happily dissociate the strong bases. But whereas weak bases, they will undergo partial dissociation. Clear? Now, we'll move to the previous page. Did you observe this? Weak base and strong base. Okay? Clear? So, now we'll go with the examples of this particular strong base and weak base. Okay? This is the diagrammatic representation, and here we have no NaOH. I'll give some example like that only, or should I make it next page? Okay, yes, I'll do it in next page for with the names, indications and all. Okay, yes. Now the heading is like this: strong base and weak base. Strong base and weak base. Now, what's the heading now? Heading is all about examples. Examples of strong bases and examples of weak bases as well. Okay. The first example in strong bases is previous one. What is that? Very good. NaOH. What is that? NaOH. What is NaOH, children? Named of NaOH? What is the name? Name we call for the chemical formula NaOH. What is that? Very good. Sodium hydroxide. Super. Sodium hydroxide. And next, second example, KOH. What is KOH? Very good. Potassium hydroxide. Potassium hydroxide. Okay. One more example. Let's take BaOH twice. What is that? Ba means? Ba means? What? What is Ba? Ba means? Barium. Very good. Barium hydroxide. Very good. Now, one more example for you. That is nothing but CaOH twice. What is CaOH twice? Come on, tell me. CaOH twice. What is CaOH twice named as? Calcium hydroxide. Calcium hydroxide. Children, so many have doubt regarding this particular calcium hydroxide, where I can say the calcium hydroxide is definitely a strong base but not at all a weak base. You know why? Because based upon the definition what we considered the bases will undergo complete dissociation, right? So here the calcium hydroxide dissociates completely. Okay, but it is having very less solubility. Okay, it is only slightly soluble in aqueous solution but not completely. It is only slightly soluble in aqueous solution, but if it solves, what happens, you know, it will completely dissociate their particular OH minus ions. In that particular state, if we consider that particular definition, we have to write calcium hydroxide in the strong bases category but not in the weak bases. Okay. In many of the books they represent like this, but if it is in the case of dissociation, complete dissociation, we have to write in the particular strong base category. What is that? Calcium hydroxide. Once again, calcium hydroxide. Okay. These are the examples of strong bases. Okay. And we will write with the weak bases. Weak base example, NH4OH. What is this? Come on, tell me, what is that? Very good. Ammonium. Continue. Very good. Hydroxide. Ammonium hydroxide. Next. What is MgOH twice? Before page I took an example, no? What is that? For weak base, MgOH twice. Yes. So I'll write here. What is that? Named magnesium hydroxide. Okay, clear? This is the example category for strong base and this side is the example one for weak base. Clarity? Did you get that? Okay. So how these are dissociating now? How these are dissociating? NaOH is dissociating into Na plus and OH minus. Now KOH into K plus and OH minus. Now BaOH twice into Ba plus 2 and OH minus. Ma'am, how did you get all these things? I am not understanding anything like that. If you say, I just recommend you to do the names of the elements in the periodic table. If you see, go with the watch with the periodic table, the group 1 elements are there, no? The group 1, or we can write 1A, elements such as hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are having valency number 1. What is that? They have valency 1. Okay. And the group 2 elements, are also called as Roman number 2A. They are beryllium, magnesium, calcium, strontium, barium, radium. Okay. These group 2 elements will have valency 2. Hence, for sodium and potassium, I wrote here only plus. You know why? Because they have the valency only 1. So, Na plus and K plus. But for barium, it is represented with that of group 2. So, valency will be 2. That's the reason plus 2. Okay. And the last example is calcium hydroxide, right? It will dissociate into Ca plus 2 and OH minus. OH is always only 1. OH minus. In acids, it is H plus. Very good. So, these are all the examples for strong bases. And one more important point to be noted is that, okay, the group 1, which means that, are also called as Roman number 1A. Okay, those metal hydroxides, okay, the group 1 metal hydroxides are very strong bases, okay. For example, LaOH, NaOH, KOH, RbOH, CSO, etc. Okay. H is not a metal, it is non-metal, so I will not write that like that. Okay, I will just represent all these things. Okay. So, these are strong bases, very strong compared to all the periodic elements. Okay. And comparatively, the group 2, okay, this group 2 or Roman number 2A, metal hydroxides are just strong. That's it. Comparatively, who is strong, children? Group 1 metal hydroxides are very, very strong compared with that of group 2. In the sense, we can write MgOH twice, BeOH twice, 2. Valency 2, no? This 2 comes with the particular OH, 2 like this, so on. Okay. So, these have less strong compared with that of group 1. Okay. So, I will write like this, the representation of like this. Okay. Dissociates into Na plus sodium ion and OH minus hydroxyl ion, potassium ion, hydroxyl ion, barium ion, hydroxyl ion, calcium ion, hydroxyl ion. Clear now? This represents how to write all these things. Don't worry if you don't know all these things. We will discuss all these things in the periodic classification lesson. Okay. How to write, how to represent all these things. Okay, children, clear now? This is all about the strength of the particular basis of strong bases, and coming with that of examples of weak bases, we have NH4OH and MgOH twice. Okay. NH4OH into ammonium ion and hydroxyl ion. Here it will be magnesium ion and OH minus ion. All this weak and strongness is depending upon only dissociation. If it is having complete dissociation producing high concentration of hydroxyl ions, it will consider as what? Strong basis. And if it is undergoing partial dissociation upon considering with the low concentration of hydroxyl ions, that is represented with the formulas and the weak base examples, such as ammonium hydroxide and magnesium hydroxide will undergo partial dissociation upon the aqueous solution. Okay. This is all about the strength and the, on the basis of strength we can do it like this. Okay. Clear now? We can also write like this, children. See, if it is NH4OH, it gives rise to NH4 plus OH minus. Okay. If it is MgOH twice, we can represent double arrow mark Mg plus 2 plus OH minus, and dissociates like this. Dissociation, okay, means separation. Clear? So, it undergoes only partial but not complete dissociation, only partial dissociation, and this for alpha will be less than that of 30%. Okay. And for this particular strong basis, we can represent NaOH as Na plus OH minus, KOH as what? K plus OH minus, and for barium hydroxide, Ba plus 2 plus OH minus, and last one, calcium hydroxide. For this, what do you represent? Ca plus 2 plus OH minus. Okay. For all these, the alpha value will be greater than that of 30%. So, all these are about the classification of bases regarding on the basis of strength, okay, strong and weak bases. Okay. These are the basis of strength, mathematical definitions and derivations, and with the particular values, dissociations, diagrams, and the examples for you, and the dissociating things. Okay. This is all about the basis of strength, the classification of base. First class, that is on the basis of strength. In this video, you watch regarding the basis of strength. No? In the next video, you will watch regarding the concentration and acidity as well. Okay. Here in the session, children. Thank you.